So in this lecture, we'll discuss how to use SAS Enterprise Miner for exploratory data analysis. So in particular, we're going to focus on StatExplore. That's a tool available in SAS Enterprise Miner to get some basic information about the data. And we'll discuss all the remaining tools in future lectures. And here's the property panel of the StatExplore node. And we can use this node to get some statistical property of the input data set. We get some summary information, for example, mean and variance and so on and so forth of the data. We also calculate the correlation statistic between the input and target variable, and we can select important variables for future analysis. So let's run StatExplore node in SAS Enterprise Miner. So click SAS Enterprise Miner. And then open the project called Start. Since we have created a diagram last time, so we'll just click the HMEQ analysis. All right, so we discussed HMEQ. This load is loaded by SAS file, and file import is loaded using a CSV file. Okay, so we just look at, we can use either one of them. So for example, I just use file import. So we can use file import to get some preliminary information about the data. But before that, make sure your variables names and rows and levels are correct. So to check that, click this, and that is our target variable, and all the remaining are input variable, and the level of batch should be binary, and the level of job should be nominal, and level of the reason should be binary. Okay, so double check and correct if that's wrong. And then we're going to click the imported data and click these three dots of the import data. All right, and then select data and click Explore. All right, now you can see the summary information of the data set, number of rows, number of columns. And this part gives you some other sample statistic. For example, there are roughly 4.68% of missing in the job. And you can see the mean, minimum value, maximum value are the mode of all the variables. And bottom, you can see the whole data set. So that's the summary information about the data. And next, we're going to see how can we use the StatExplore node to get some other statistical properties. So to add a node, we just right-click, add node, and StatExplore is in the Explore toolbar. So select StatExplore. All right, and then we want to connect these two nodes, so that SAS Enterprise Miner knows to use this data for the StatExplore. And then if you look at the property menu of the StatExplore, you can see import data, export data, variables, and number of observations. And here for the chi-square statistic, so that's the one we're going to focus on. So for the chi-square statistic, make sure the chi-square is specified as yes. And for the interval variable, we will also calculate the chi-square values. So we'll select yes for the chi-square statistic. And number of bins, that's to say, when we calculate a chi-square statistic for an interval variable, we split the interval variable into 5 bins and then calculate that. All right, so after we specify the interval variables, we're going to run the StatExplore. To run that, to right-click StatExplore and run. And we may need to wait for a while for the completion because the data is huge. All right, step. And then we should click the results. And now you see the outputs. The first one is called chi-square plot. Okay, basically give you the chi-square values of each input variables. So we will discuss in details how to calculate these variables later on. And here in the bottom, that's called variable worth. So variable worth give you a sense of the importance of each variable. Okay, and we can also take a look of the exact value of this chi-square for each variable by click the view table. Let's maximize this, and you will see the chi-square column that's sorted from maximized value to the minimal value for each input variables. So we have crimes v and chi-square columns. So if you go back to the slides, so that's the exact same table. The chi-square or the crimes v is a measure of the association between input variable and the class target variable. So in our case, class target variable is bad, either 1 or 0. So the larger the value, the higher degree of association with the class target. So if the target is interval, then we can calculate the correlations. And next, let's see how can we calculate this chi-square value manually. Okay, so let's use reason as an example. So chi-square is basically, that's a test to test the association between an input variable reason and the target variable called bad. So the hypothesis is that bad and reason are statistically independent. That's our non-hypothesis. So to do that, we get a table. So the first column called bad equals 0, second one is bad equals 1. And the reason, we have two reasons, debit consolidation and home improvement. We also have some missing values. And then we calculate how many customers has reason, debit consolidation, and bad equals 0. And then we get all the entries. And make sure the total sum should be 5,960. Okay? And then we can use this table to calculate the chi-square values. So the chi-square statistic is a measure of the independence. So here's a formula of the chi-square statistic. Basic intuition is that if we denote OIJ as observed frequency for the cell IJ and EIJ as the expected frequency for cell IJ if independent. So basically, if these two are independent, we can calculate the expected one. And then we calculate the difference between the expected one and the observed one and divide by the expected one and sum over all the entries. So that's called chi-square statistic. And we have the degree of freedom, basically that's the number of rows minus 1 times number of columns minus 1. So if chi-square statistic is large, means these two variables are not independent. And if we have a larger chi-square, means strong evidence to reject H null. Okay, and let's see how can we calculate this chi-square value our table. So here the tricky part is how to calculate the expected frequency. So expected frequency basically that's under assumption of these two variables, bad and reason, are independent. So if these bad and reason are independent, then take a look at this entry, home improvement and bad equals 0. If these two, reason and bad, are independent, this entry will be equal to the total sample size times the total number of bad equals 0 divided by total sample size times the total number of home improvement over total sample size. So you get 1424.9. And similarly, we can calculate the values for all the 6 entries. So that's expected frequency. And then after you calculate expected frequency, you just plug in the formula for the chi-square. We get the values. So that's the chi-square statistic for the first entry, second entry, third, fourth, and so on and so forth. So sum all these 6 cells, we get the final one, chi-square equal 8.39. So that's the sum of the 6 values. And degree of freedom is number of rows minus 1, 2, times number of columns minus 1, 2, 1. So total is 2. And if you check the chi-square table, get the p-value is 0.0151. So this will be exactly equal to the one shown table, chi-square values, and the p-values for the input variable called reason. Okay, so basically these two say if the alpha equal 0.05, then we can reject H null to say these two are not independent. All right, so in this lecture, we'll just discuss how to use StatExplore to do the preliminary information of EDA. And then in the next lecture, we will discuss how to use GraphExplore to get the graphical representation of your data.